Good morning, class. Here's elementary statistics practice test number 1, covering module 1, chapters 1, 2, and 3. Here's chapter 2, exploring data with tables and graphs. Again, here's a pledge. Before starting the exam, any one of the exams, please read and adhere to the following pledge. I pledge on my honor that I will neither give nor receive unauthorized assistance during this exam or any other exam. Unauthorized actions include but are not limited to the use of notes, text, search engines, PowerPoints, AI, or any other resources not explicitly allowed. You may use formula sheet, tables, and graphing calculators, but of course, graphing calculators within reason. Having said that, let's get started. Given the frequency distribution table, short FDT, answer the following questions. The number of classes in the table is. So first and foremost, what is a frequency distribution table? A frequency distribution table is a statistical tool used to organize and summarize raw data. It breaks down data set into distinct categories or intervals called classes. This is the first interval, second, third, fourth, fifth, and shows the exact count or frequency of data points that fall into each group. So having said that, notice this is 1, the first class, second, third, fourth, fifth. Therefore, the answer for the first question is 5. The number of classes. How many classes? 5. Number of statistical age group defined. What is the class width? Okay. There are a couple of ways to calculate the class width, this width, from 11 to 20, for example, from 21 to 30. That's what we are referring to. The width is UL, upper limit, minus LL, lower limit, plus 1 unit. So if you pick any class, if you pick this one, the upper one is 20, the lower one is 11. So 20 minus 11 plus 1. And by 1, we mean 1 unit, because sometimes that may represent 1,000 or 0.1. So 1 unit rather than 1. If you look here, 40 minus 31 plus 1. If you look here, the same thing. So that's one way to do it. Here's the second method. Upper limit minus lower limit plus 1 unit, or difference of 2 consecutive lower limits or upper limits. For example, look at this one, 21 minus 11, or 30 minus 20, or 51 minus 41, or 60 minus 50. That gives you the same answer, namely 10. Okay? So whatever is easier. Again, I want to erase my work. The midpoint of the fourth class, the midpoint is really average for that class. So you pick the given class and you add up the limits and divide it by 2. So let me erase my work. So we are talking about the fourth one, this one, 41 and 50. This is the lower limit, this is the upper limit. So the formula, midpoint is lower limit plus upper limit divided by 2 for each class. So that makes it 41 plus 50 divided by 2, which is 45.5. That's how we find the midpoint. The lower boundary of the fifth class. So the fifth class is this one. This is the lower limit. What is the lower boundary? You have to add these 2 up, divided by 2 becomes the upper boundary of the previous lower boundary of the next one. So these 2, 50 and 51, add them up, divide by 2, you get 50.5. So here's how you find the boundary. 50 plus 51 divided by 2 is 50.5. midpoint of the upper limit of fourth class and the lower limit of fifth class. This number, 50.5, is considered the upper boundary for the fourth class, lower boundary for the fifth class. Okay, and we'll look at this with more details later. The upper limit of the first class, it's already discussed. This first group, those are all lower limits. Lower limit of the first, second, third, fourth, fifth class, upper limit of the first, second, third, fourth, fifth class. Therefore, we are looking at number 20. Upper limit is 20. First class is 11 to 20, and this is the upper limit. What about the sample size? So frequency, that means from 11 to 20, we have 5. From 21 to 30, we have 6, and so on. Frequencies must be added up. So 5 plus 6 plus 9 plus 11 plus 4, that is n, the sample size. By the way, if it is a sample, lowercase n. If it's a population, uppercase n. So a quick recap. We have a frequency distribution table. Okay. Raw data has been summarized, as you can see. 11 to 20, we have 5, so on and so forth. Therefore, this gives us 1, 2, 3, 4, 5 groups or classes. Class width, upper limit minus lower limit plus 1, or just pick up any two consecutive rows and either take care of the lower limits or upper limits. The midpoint for any class, add them up, divide by 2. For a boundary, you have to find, for example, if I want the boundary here, I'm going to add these two divided by 2, and I get 20.5 here. And what is the sample size? Add up the frequencies. All right, let's move on. The relative frequency of the first class. So that's what we want to discuss now. So relative frequency, by definition, RF is F over N. That means the number divided by the total size. That's the percentage or relative frequency. And of course, depends how they want it. They want it in the form of a fraction or a percentage and so forth. So obviously, if I want this for any class, I'm going to pick the number and divide it by the total size. We already have, and I'm going to remind you, here's the group, here's the class width, here's the n. Therefore, F over n for this one would be 5 over 35, this one 6 over 35, 9 over 35, 11 over 35, 4 over 35, and you simplify. Now, you always write the exact answer, which is a fractional format 1 over 7, unless they ask for a percentage. Okay? And as you can see, those are the answers. And whatever we can simplify, we must. Now, reminding you what we discussed as far as the boundaries. Boundaries are the midpoint between the upper limit of one class and the lower limit of the next class. So those are the midpoints. Therefore, just for the sake of argument, if you find one of them, if you find one of them, these two, for example, 20 plus 21 divided by 2 is 20.5. That means this is UB upper boundary, LB lower boundary. This is 20.5. And so is this one. And what it really means, I want to make sure that you understand the meaning of that. So this goes all the way to 20.5, but it's not including 20.5. 20.5 actually belongs to the second. Then do I have to calculate it in the same manner for the rest of them? No. I know the width is 10. So all I have to do, add 10. 30.5, and I do all the way to the end. What about this one? 20.5 minus 10. So it's 10.5. So that's very easy. I just wanted to mention how the boundaries are found. Fairly nice and easy. These are the answers. Let me erase my work. So that's as far as the boundaries is concerned. Next one, find the modal class and the mode. Remember, mode is the one with the highest frequency of occurrence in a data set. And by the way, the midpoints, I showed you how to find the midpoint for one of them, and now for all of them. 11 plus 20 divided by 2 is 15.5. Again, do you have to do it for every class? Now, because this is 10, just keep on adding 10. So which one has the highest frequency? Number 4. So the modal class is the one with the largest frequency. Class number 4, which is from 41 to 50, with largest frequency of 11. So what is the mode? You use the midpoint. All right, so now the following frequency table describes the speeds of drivers ticketed through a 30 miles per hour speed zone. Calculate the relative frequencies for all classes. So what is given is the frequency distribution table. As we said, RF, or relative frequency, simply is F over N. And so the very first thing we have to find the N here, which is 25 plus 14 plus 7 plus 3 plus 1. So N, or summation of X, is 50. So if that is the case, for this one, for relative frequency would be 25 over 50. Second one, 14 over 50, 7 over 50, 3 over 50, 1 over 50. And 25 over 50, of course, is 1/2. What percentage represents the speed of 53 miles per hour or less? Well, 42 to 45, 46 to 49, 50 to 53, all the way to here. So we need all of those, and we're going to mention cumulative frequency distribution of 53 miles per hour or less refers to the first 3 classes. Therefore, because we want the percentage, we can add these 3 numbers. Okay, and we get 0.92. This is 1/2, or just 25 plus 14 plus 7 divided by 50, and then change it to a percentage. Twenty-five, 14, 7 divided by 50. And that's the answer. That's the exact answer, anyways. What about the boundaries? Reminding you that the boundaries are the midpoint between the upper limit of one class and the lower limit of the next class. So First, let's put these two together. 45 and 46 divided by 2 is 45.5. And what happens is this 45.5 is the upper limit of the first class as well as the lower limit of the next one, okay? Meaning everything all the way to 45.5, but before that, less than 45.5 belong to the first one. But from 45.5 on, belongs to the second one. Now, what we can do, we can calculate it for each case, but it's faster and easier if we calculate the width. The width is 4. Okay. Why is the width 4? There are many different ways. 45, let me just do it two different ways. One of them is say, okay, over here, 45 minus 42 plus 1. Remember, upper limit minus lower limit plus 1. Or just pick any two, doesn't matter. 57 minus 53 is 4. That's all. So if that's the case, then just add 4 and I get 49.5 here. The same thing here. Okay, and I continue. This one, I'm going to subtract 4 from 45.5 and I get 41. So it's very straightforward, everybody. Let me erase my. All right, we're going to continue with the same question. We want to construct a histogram corresponding to the frequency distribution table. So in order to do that, we are going to remind everybody what the boundaries are. Over here, we can go with the boundaries. We can go even with the limits. We can even go with the midpoints, okay? But it's a good practice to go with the boundaries. And here's the frequencies. Okay. So, for example, the first one from 41.5 to 45.5, you put number 25 here. That would be the box. And the next one from 45.5 to 49.5, we put the next one is having a height of 14 and so on and so forth. Okay. Finding the width from the histogram. If limits are given, the width is calculated as follows, and we do not add 1 as I explained before. In MOM, my open math, of course, the best course of action if you have the boundaries. What is the width? 45.5 minus 41.5. If this is not given, you have this one. You have the histogram. Or 49.5 minus 45.5. Or 61.5 minus 57.5. That's the width. But even if the limits are given, they take it to be that way. So just so you know. Now, in this case, we are repeating the same question. However, the following frequency table describes the speed of the drivers and so forth. Prepare the cumulative frequency distribution, prepare the cumulative relative frequency distribution. And this is extremely important to understand how it's done. There are different ways of approaching it. All of them are correct. You want to follow the methodology that they use. So if we want to go with the limits, the first one remains. But the second one, cumulative, always the upper limit comes from the class of interest. The lower limit is always 42. If you want to go with the boundaries, remember the boundary, this was 45.5 for the first one, and then you add 4, right? 49.5, 53.5. So there are two ways to write. If you go with the limits, the lower limit is always this one. That's the meaning of cumulative. Okay. Or if you want to go with the boundaries less than 45.5, less than 49, remember 45.5 itself belongs to the next one, so on and so forth. Okay. Now, what about the cumulative frequency that we want to write here? Well, 25 remains, but this one now, since it starts from 42, is 25 plus 14, then add 7, then add 3, then add 1, and the last one must always be n. The last one must always be n. What about the relative frequency? Well, just as before, 25 over 50, 39 over 50, 46 over 50, 49 over 50. The last one must always be 1 or 100%. 1 or 100%. So we already have all the information. The following frequency describes the, speed of drivers ticketed in a 30 mile per hour speed zone. Draw an ogive of the cumulative percentage. Now, here's what happens. When it comes to ogive, we must use the boundaries for the horizontal axis. Therefore, it's a good practice to use the same thing for everything, including histograms. So how does this work? The lower boundary of the first class corresponds to 0. So we start from 0. Now, if they said frequency, the upper boundary of the last class corresponds to frequency, but they said percentage, this corresponds to 1 or 100%. So that's the first thing I want everybody to know. So the lower boundary of the first class, 0. The upper boundary of the last class, either 100% or 1 or 50. Which one, depending on the question. The question is asking for cumulative frequency, then you go with 50. Percentage, you go with 100%. Okay. In between, so for example, this one is 50%. So right here corresponds to 50%. And then you connect them with the line segment. The next one is 78%. So you locate 78% and you connect them, and you do the same thing with the rest of them. And it'll look something like that. I'm going to erase my work. Of course, this is much more precise. So that's how you find this. Using the OGI, find the percentage of drivers who drove 47 miles per hour or less. So we're going to locate this number, 47 somewhere here. And then find the number here, and that would be the answer. So number 47 is somewhere between 45.5 and 49.5 on the horizontal axis, which corresponds to approximately 60%, therefore 60% or maybe 61% of drivers drove 47 miles per hour or less. So that's pretty straightforward, everybody. Okay, so let's move on. Given the following sample, which is the ages of 40 tenured faculty at CSULB n equals 40, construct a dot plot, construct a stem plot, and let's see how we do that. So first and foremost, let's discuss each one. Definition. A dot plot is a graphical display of data using dots for relatively small data sets where values fall into a number of discrete values or categories. Data values are plotted as dots along a horizontal scale of values. Equal values will be drawn as a stack of dots. Okay, so that's the definition of a dot plot. And so the very first thing we do, we are going to go back to the data and arrange it from smallest to largest. Clearly, the smallest value is 32, the largest is 63. So rank them, sort them. That's the first thing we must do. So the smallest is 32, and the largest is 63. So we come up with sort of a number line, maybe let's say from 30 to 65, or maybe from 30 to 70. So, or even from 0 to 100. You can go from 0 to 100. Either way, some sort of a, number line. And we start working on number 32. So we notice there's only one of them. We locate 32. So this is 35, this is 40. So 32 maybe somewhere here, you put one dot. Then 37, somewhere here you put one dot. 39, one dot. 40, one dot. Same thing with the rest of them until we get to 47. Now 47, so this is 45, this is 46, this is 47. I need 1 and 2. Let me just show you. So I need 2 dots here. So all of them, I put 1 dot. For example, again, this was a dot, this was a dot, but this one now I have how many? 2 dots. And this thing continues, okay? And the final result looks like this. Let me erase again my work. So you put 1 dot for one number. That's it. So when 47 has 2, you have to put 2 dots. 53 has 1, 2, 3. So this is 50, 51, 52. Here's 53, everybody. So how many dots? 1, 2, 3 dots. 54 happen to have 3 dots also next to it, 3 dots, and you move on. What does it indicate? Clearly, the ages range from 32 to 63 years. Also, there is more tenured faculty at older ages. See, we have more dots at older ages. So that makes perfect sense. I hope everybody's okay with that. Now we are looking at the same question, but this time we're going to construct a stem plot or stem and leaf plot. So what's the definition? Definition, stem plot, stem and leaf plot display the data in order from smallest to largest. That's why I put the ranked one, the sorted one here. We're going to use this one. So the first step is the same as before. A stem plot, like a histogram, is a tool to help you visualize a quantitative data set. And that's the key, has to be quantitative. The name stem plot is because there is one stem with the largest place value digit to the left and one leaf to the right. We can see the distribution of data while keeping the original data value. What do we mean by that? So notice it goes from 32 to 63. The larger the digit, okay, the tens would be 3. So we're going to go with 3, 4, 5. Okay. So with 3, we have only 37 and 39. So we're going to keep the 3 and we're going to put 7 and 9 here. So if anybody wants to read this line, would read 32, 37, 39. 3 numbers having the tens digits as 3. The next one is 4. So let's look at all of them which start with 4. Therefore, we're going to write next to it 0, 2, 3, 5, 6, 7, and we have to repeat it 7 again, 8, 9. It's important to repeat that. Meaning, if somebody wants to read this, we'll read 40, 42, 43, and the rest of them. And of course, more importantly, it's, for example, 47 is being repeated. Now, the next one is 5. So I'm going to put 0, 1, 1, 2, 3, 3, 3, 4, 4, 4, 5, 5, 6, 6, 7, 8, 8, 8, 9, 9, 9. That would be the next group. And the last one, I'm going to put a 0, 0, 1, 1, 2, 3, 3. That's how it works. Again, what do you see? The ages range from 32 to 63 years. Also, there is more tenured faculty at older age. So very straightforward, everybody.